In this tutorial, we will be discussing buffers. A buffer is a solution that maintains its pH level, and it could vary from one area to another. It doesn't necessarily always have to be maintaining a 7, a neutral. It could be trying to maintain a 1.5 in the stomach, or it could be trying to maintain a 7.4 in the blood. It all depends on what buffer system we're looking at. So if we look at this top area here, this is a non-buffered solution, just a regular solution. And if you add acid to it, notice that the pH drops to a 4. It went from a 7 to a 4. If you add a base to it, it goes down to a 10.5. So it goes to a very large range. However, if it's a buffer system in there, if you add acid, it only goes up to down to a 6.9. If you add a base, it only goes up to a 7.1. So you'll see how it stays within a certain range. So buffers work because they can resist the change in pH from adding an acid or a base. So in the body, they absorb H3O plus or OH minus from the foods or different processes our cells are going through to maintain that pH. Without these buffer systems, our bodies would shut down. We need these buffer systems to survive. They maintain a pH in the blood, for instance, close to a 7.4. If the pH in the blood went too far beyond that range, we would essentially die. A change in the pH of the blood affects the uptake of oxygen in the cellular processes. So in order to have a buffer system, it contains a weak acid and the salt of the conjugate base. Salt, remember, is just a generic term for an ionic compound. So for instance, this might say Na out here. So Na plus C2H3O2. But we don't look at the Na when we're actually looking at the system, because it's just floating in solution. There's equal concentrations of both of these, and they both have very important jobs. So how a buffer works is, here's the buffer system. Notice that Na, the sodium, is in there, but we don't really consider it. Both of these compounds are in a very high concentration floating around. So it's actually in a liquid. It's in water. If we put an acid in here, this negative here can actually absorb that hydrogen and take it out of the solution. If we put a base in there, we could actually donate that hydrogen here and make it so it gives up a hydrogen. So the function of a weak acid as a buffer in a buffer system. So if we put an acid in there, what could happen is the hydrogen could be donated over to that base. If we put a base in there, the hydrogen from the acid could be donated to that OH minus to then produce water and neutralize the system. If we put an acid in there, the conjugate base does the work. It takes one of these hydrogens away from the H3O plus and pulls it out of the solution, and making that H3O plus turn back into water. So once again, it's basically taking out and adding to the solution to create water, so therefore making it more neutral. Buffers work because the weak acid in a buffer neutralizes the bases, and the conjugate base neutralizes the acids. So we can actually determine which of these are buffer solutions and which are not. For instance, HCl, that's a strong acid, that's not a weak acid, so that would not count. H2CO3 and HCO3, that would work. You have to make sure that these parts here match up, and it's only giving up one hydrogen at a time. H3PO4 and NaCl, that would not work because of the fact that these are not conjugates of one another. Then finally we have acetic acid, C2H3O2, and the conjugate base of it. the conjugate salt of it, KC2H3O2. That would work once again. So you need a weak acid and the salt of the conjugate base. And that's how buffers work.